type in those ones
The piecewise?
yeah, I guess.
Okay.
Is that how to type that in?
You can do it, and that will make it in separate pieces, but you can also do it on one line, because this will try to connect. It might not. Let's hit graph and see.
Yeah, it's weird when it graphs it, but that's what it does.
Okay, but it would be a constant when x is less than -1, but it's up to 13, so we probably need to look at your window. So,
Sorry.
actually, it doesn't matter what that is. That's not an issue.
Well, according to the graphs that's on MathLab, it does go below.
It needs to go up to about 20. Let's see if we see it all. Okay, so there's for less than 1. What happened to the parabola? Okay, there comes the parabola.
That's what that does not at all match
No, it doesn't.
what's on the.
Let me look at it again. Okay, it doesn't like this. Okay, what you have to do for that.
Instead of using or equal to.
Come on.
Greater than instead of.
No, you want to leave that where it is, and then let's insert a parenthesis, open one, and put in x, and it should do it now. What it is you have to have both of those in there, but it has to be separate, and then this should do it. Let's hope.
It looks more like it.
Yeah, it actually should be this part and that. Can't figure out where it's getting the rest of that from. There's nothing else in there.
I just don't have my.
Are you sure? Are you sure that equation's right?
Yeah, type of look at it, type in definitely.
Because
It's on problems.
so it's actually 13 and 13 for both the first one. Send me a text either in Shelby or in our mind and say, would you tell me what problem it is? And let me look at it. Because you've got it in there that it should show you the right graph, and it's not. Well, I think I might know why it is though, because what's happening when you put that restriction in there, what it's doing is as long as the x is within its domain, it graphs that value, like 13. But when it's not, it drops down to 0. Because what it's doing is, yeah, and so there's some extra straight lines at the axis that are coming up that aren't part of the graph. So basically it should come across at 13, then you've got that little piece of a parabola, and then it should come across at 13 again. And that should be all it is. Yeah. Your calculator is just trying really hard to show you that the rest of this is not in the domain of that.
Do you know offhand which one would it be? The straight line that has the solid circle and the parabola that has
The parabola, because it has the equals to in it, has the solid circles, and the straight line has the open circles.
I wish I could come see you.
it gives me this problem, and then it tells me to go to, like, the table and, like, punch in all these, but I don't get, it's as X approaches 3 to the right. But I think, like, what it's telling me is that's giving me to the left. Well, no, I don't
Yeah, this is to the left. If you're approaching 3, this is to the left. And then, actually what's happening here is it's kind of backwards. Although that is meeting kind of in the middle.
Because, shouldn't these be, like, I thought these should be, like, somewhat close to each other. Like, they should be approaching in on one number, right?
You have an undefined though at x equals 3. So if you check your graph, that table will make sense. So let's go do the graph. So what's happening at x equals 3?
Nothing. Like,
There's an asymptote, okay? So what's happening is you approach from the left, it's going down to negative infinity. When you approach from the right, it's going up to positive infinity. And that's what the table is trying to show you, is it starts out a little negative, but it goes really, really negative, really fast. And then on the other side, it starts out a little bit positive, but as you go closer and closer to 3, it goes up to infinity.
So I'm confused on what it's asking, because when I put those numbers in the computer, it's taking it. Like, it says,
Yeah, because it's not these numbers, it's infinity.
oh,
Okay? It's infinity.
all right.
Because, okay, look at this. If you did 2.9999, 2.999999. Now you're into scientific notation. So what it's doing at this point is adding zeros. Okay? If you put your cursor on that, that is negative 3,732,050. And if I put in 2.123456789, that's a whole lot of 9s, even though the calculator says it's 3, that's really what it is. But if you go over here, look how negative that number is. So it's going down to negative infinity. And the same thing is happening when you do,
We're just going positive.
except it's going up. Okay?
Okay.
And when you look at the graph, that kind of would make sense.
Right.
Okay?
All right. Thank you.
Okay, folks, we need to get started. If the camera will come on. Your test is going to be on Tuesday. I have put a practice test in Shobi for you, and I have unlocked the 11.4 Shobi homework, and we're going to finish up 11.4 today.
Is
Okay.
the study guide on there? I saw one study guide, kind of, but it was from like before this class started. Is that the right one? Or I can't find one that's.
Did you go to Shobi?
Yeah, that's what I'm on. All it says is chapter 11 exam review, but it's just a bunch of different questions. And it,
Let me look.
Yeah, it looks
It may be from another one because I didn't look to see if the old one was up there.
Yeah.
I just posted the new one.
So are we doing 11.4 today, or are we doing start chapter 11?
No, we're going to do 11.4 today. We're not finished. We probably should start chapter 12, but there's no point in going to chapter 12 if we're not ready for it. I'll just have to adjust the calendar. Okay, the one that is for this is practice exam 1.
But is there like a study guide? Like, I thought there was going to be a study guide out.
This is the study guide.
Is that due?
How do we know
Is that
what?
like an actual graded assignment?
Yes,
Practice exam is?
yes.
Oh, but the answers will be put out before.
But I'm going to put the answers up, and if you look at it, it shouldn't be, this is just like the test. Okay, it is honestly, literally a practice test. So if you do this and get it done, then you'll do very well on the test. Okay?
Are there answers? Are there answers up for the practice exam?
Not yet. There will be. There will be. So, none of these should look totally unfamiliar to you. So what I was doing when I put this up there was I was trying to give you as much knowledge about what the test was going to look like as I could give you.
So how much of a percentage of the grade is that?
This is just a show me homework grade.
Well, okay, because I'm probably not gonna be able to finish practice test. I've still got a lot of homework stuff to do, so.
Okay, if you missed the practice test, do what you can of it. But, you know, if you have to skip the other show me homework, you can do it that you don't have time to do, that's fine. I'll look at my math lab and see if I can trim those down and so you'll have time to get done. Okay?
Which one would you like us to prioritize?
I would like you to prioritize this practice test above anything and everything else. Just because I think that's where, this tells you what you need to know. Okay?
Okay, is this practice test in Shelby?
It is in Shelby, and the answers will be posted by Saturday. I may post them later on tonight. I may post them tomorrow, but you'll have the answers to it. So as you can see here, there are 10 questions on the test, and the last 2 pages of the test are your formula sheets. This is the exact formula sheet that you'll have. So you've got the same formula sheet to do this that you'll have for the test. I am going to show you how to do this. It's in the PowerPoint, but I'm going to try to show you how to do that separately because it isn't something you have to know to be able to do the test. Okay? Calculating numerical derivatives with the calculator. You don't have to know how to do that. The test doesn't require it. Okay, so we really don't have much left, even though it looks like if you went through the PowerPoint, it looks like we've got a lot left. What we're going to do today is we're going to practice what we learned last time by doing some more examples. The main thing I want you to understand, the difference between these two. A difference quotient, f of x plus h minus f of x over h, is the slope of a secant line, the line that touches in 2 points. Okay? That's a secant line. You have x and f of x, and you have x plus h and f of x plus h. So you have 2 points, even though they're really, really, really close together. You have 2 points because h is only just a very small number. But that's the slope of a secant line. That gives you what's called the average rate of change. It gives you average velocity if you're talking about traveling through time. It will give you the average rate of change in cost, revenue, or profit, which is the kind of application you're interested in. The difference in the difference quotient, which is the slope of the secant line, and the derivative is that you take the difference quotient, but you take the limit and let h approach 0. And that's called the 4-step process, and we're going to practice that today. It gives you the slope of the tangent line, not the secant line, the tangent line. It's the instantaneous. It's not an average rate of change. It's the rate of change at one single instant in time, or one single instance in your production, at one single value in your production. So it gives you what we call marginal cost, revenue, or profit. What you learned in 1630 is that marginal means rate of change. Okay? Marginal is your changeable cost. You have fixed costs, which is your y-intercept, and your marginal cost, which is how much it costs you to make each item. So it's cost per item. The derivative gives you cost per item at any particular number of items, or profit per item for any number, any particular one single value of items. That's the difference between the two. So here's where we're going to pick up. We have f of x equals x squared. This is where, if you struggled in the prerequisite skills with finding the difference quotient, the f of x and f of x plus h and f of x plus h minus f of x, those problems, if you struggled with those, this is going to be more challenging for you because it requires that you not miss signs and that you be able to multiply and divide your polynomials right. Now this is a simple one. Okay, this one's not a tough one. We want to find the derivative of that function. And the derivative, you're going to learn that f prime is the notation for the derivative. That's the notation we're going to use from here on out. F prime of x is defined by the limit as h approaches 0 of f of x plus h minus f of x divided by h. And I hope it's obvious to you why h can't be 0. You can let it get really small and approach 0, but you can't let it be 0 because then you're doing something that's a travesty in math. It breaks the cardinal rule. It's a cardinal sin in math. Okay? So what we're going to do is we're going to use this function and we're going to replace x in both these functions with x squared. Okay? So f of x plus h. So x plus h is going to be x squared plus h. I'm sorry, not x squared plus h. It's going to be x plus h because we're putting in x plus h in place of x. So that's going to be squared. Minus f of x is just x squared. And that's all over h, and we're still going to take the limit as h approaches 0. Now what is x plus h squared? What is that quantity squared? What happens when you multiply x plus h times x plus h? X squared plus 2xh plus h squared. Okay? If you can't do that in your head, remember you can always go over here and actually FOIL it out. X times x, x squared, x times h, xh, x times h, xh, and h times h, h squared. So where the 2xh comes from is the two middle terms. So this is x plus h quantity squared. And from that, we are going to subtract x squared. Now, I can bring all this down, all the way down, but basically what's happening is this is always the limit, all the way to the bottom. And all of this is always going to be divided by h. So what happens to my x squareds up here? Now, x squared minus x squared disappear. They kill each other off. So what I have left then in the numerator is 2xh plus h squared over h. And since you notice here that you got an h and an h squared, you factor out that h that's in both of those terms. So h times 2x is 2xh, and h times h is h squared. It's still all over h. And we're still taking the limit.
Can you explain why you just factored that?
Because I want rid of that h in the bottom.
Okay, so in order to get rid of that, you have to get it by itself.
Yes, you have to get it by itself. So you want to factor out the common factor in the numerator so that you can get rid of the denominator. So this factoring is actually just a means to an end, the end being I don't want any h's in the denominator because I can't have it be 0. Okay? So at this point, what happens to the h's? Well, the 1 in the bottom cancels out the 1 in the top. Now, granted, we still have 1 left. We still have an h left, but now this is a much simpler question because now what we're being asked is what is the limit as h approaches 0 of 2x plus h? What happens to the quantity 2x as h gets really, 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 really small and finally, eventually disappears? What happens when h disappears? It's just 2x. Okay? So the derivative of f of x equals x squared is f prime of x is equal to 2x. That's your answer.
I have one more quick question.
Okay.
In the beginning of the problem, as soon as you started writing red,
Right.
why is the whole parentheses squared and not just x?
So the little one.
What's the name of the function? What does f do to the variable?
That's squared.
It's squared, okay?
Okay.
If the input is changed from x to x plus h, what are you going to do to x plus h? Square it, okay? Anybody else have any questions? Because it's better to try to get you to understand it while it's...
One next to the absolute.
That's a prime. It's not actually a 1. It's like, you know, if you put 5 feet 2 inches, it's the first one is just one little mark, and then the inches is 2 marks.
So the 1 has to be there for the problem to be right.
The one,
The 1.
the f prime,
Yeah.
yes, the prime has to be there because that's what we call the derivative. It's either that. There's other notations for a derivative. This all means derivative. You can write the derivative as f prime of x, or you can write it as delta f over delta x, or you can write it, you know, the whole big thing, but both of those are derivative notation. And there's another one that I really hate. It's called dx, only it's dy over dx. And then some people write it that way. But this gets, that doesn't make any sense. It doesn't tell you what you're doing. This delta y over delta x, or delta f over delta x, what that basically is saying is this is a slope. Change in y divided by change in x. That's what slope's always been, right? So those other notations are just telling you in symbols what you do to get the derivative. Is you do that difference quotient, change in y over change in x. But then because it's a derivative, you're taking the limit as the denominator shrinks to 0. In other words, as the 2 points get closer and closer together until they're on top of each other. Okay? So f prime is just notation. It's not a 1. It's actually it's actually a little slant mark like that. It's a little accent mark. Any other questions about the
You
process?
have to have that in the antidote for conversion.
Yes.
And that's just part A.
That's part A. That's the hard part. Part B is easy. We haven't got to part B yet. Part B is really easy. It's one step. Okay?
Just part A.
You plug in 3 into that. Okay? So the hard part was getting part A. Once you get part A, this part isn't hard because this part says take this formula, which is f prime, f prime of x equals 2x, and this just says, okay, now plug in 3. Okay? This is called the 4-step process. And the reason it's called the 4-step process, and I'm going to make it a little more obvious that there's 4 steps you're actually taking in the next one, is the first thing you do is you substitute in x plus h into the function. Then the second thing you do is you simplify that and subtract the original function from it. And then the third thing that you do is you take what you have left after you subtract the original function from it, and you factor out the h that's going to be in both the numerator and the denominator, and you're wanting to cancel the h's. If you can't get it to cancel out the h in the bottom completely by the time you come to the last step, you made a mistake somewhere between here and here. Because there are certain things that happen at every step. So let's try another one, and I'm going to let y'all tell me more about what we're doing on this one. Now this one's not fun, okay? It's not fun. It's a little harder. Because it involves fractions, and you don't like fractions. I know you don't like fractions. Tell me, what is f of x plus h? This is the function. What does f of x plus h look like? Take x plus h and put it in place of x here and here. What does it look like?
4 over x plus h.
Exactly. Okay, so that's step 1. I'm leaving out all the stuff about the limit. We can put that on the very bottom. If this is f of x plus h, what does f of x plus h minus the original function f of x look like? Okay. Now we have to simplify that. What do you need when you're subtracting 2 fractions and they have different denominators? Kim?
Step two just says find x plus h, doesn't say f.
Hmm?
And step two of here just says x plus h minus fx, it's not f.
I've left out the limit and the denominator and everything. What, are you just writing out what I'm doing, or are you looking at the PowerPoint slides?
I'm looking at the notes.
Okay, I mean, I'm not looking at the notes, so I don't see what you're looking at. But this is the original function, this is your first step, this is your second step, minus the original function, which is 4x minus 4x. Okay?
What did you subtract when you left with H?
Hmm?
What did you just subtract for it when you left with H?
Nope. Okay, let's review arithmetic. We're gonna do an easy one with arithmetic. This was really why you learned how to do fractions a long time ago, or didn't learn because you didn't like them, but you still need to know how to do them. How do you add those two? Gotta have common denominator. What's the common denominator? 6. Okay. You already got the denominator here. How am I gonna get it over here? Okay, so I have to multiply the whole thing by 2 over 2. Because 2 over 2 means that I'm multiplying it by 1, therefore I didn't change its value. I'm just changing the way it looks. So the answer is 3 over 6. And we could reduce that, but I'm not interested in you reducing the fractions right now, okay? We're going to do the same thing here. The only thing is, here you knew that 3 went into 6, and that was easy. What if this had not been 3 and 6? What if I gave you that?
You would have to find a common denominator.
You'd have to create a common denominator. You didn't already have it on that one, you'd have to create it. How do I create it? Okay, so couldn't I just say 5 times 3? And that'll give me the common denominator, which is 15, but I'm much more interested in it, it's 5 times 3. Because if I have to do 1/5 plus 1/3, and I need a 15 on both of these, that means I need to multiply this one by 3 over 3, and I need to multiply this one by 5 over 5, right? So then I get 3 times 1 is 3 over 15, plus 1 times 5 is 5 over 15. Now I can add those two fractions together, okay? So if I add those two fractions together, they'll have the common denominator, which is 15. That's what I want to do here. What is the common denominator between x plus h and x? How do I find it? What's the common denominator?
You have to add h to x. So you have x plus h.
How did you do this? How'd you find that one? What'd you multiply?
X times. You do x times h.
Okay, times.
X plus h times h.
Okay, good. Yeah, once you realize that your common denominator's got to look like this, how do I achieve this denominator with this fraction? Okay, so 4 times x. Because it's got x plus h, it doesn't have the extra x. How do I make this have the denominator x plus h? 4 times x plus h. okay? This is the simplified version. Now, the first thing I want you to do is don't do anything in the denominator until you have a reason to. Don't necessarily multiply that out. Leave it sit for a minute, okay? This is f of x plus h minus f of x. And the only simplification that I want to do to it is I do want to simplify the numerator, and you'll see why in just a second. What happens when I take 4x minus 4 times x is what? And what is negative 4 times h?
Minus 4h.
You move it over a little bit.
Ah, thank you. Get this to where you can see it a little bit better too. Okay. And in the denominator, I still have x plus h times x. I have no real reason to do anything with this yet, so I'm going to leave it where it is. I can always multiply it later if I need to. Right now, I need to make something happen here. What happens to 4x and minus 4x? Okay. That was my goal. So f of x plus h minus f of x is equal to negative 4h over x plus h times x. So this was step 1, and believe it or not, step 2 was the hardest part in this one. This is step 2. All the simplification was in step 2. Now, what I want to do with that is I want to now find f of x plus h minus f of x, which I have right here, and I want to divide it by h. Okay? I want to put it over h. When you divide by something, what is the other way? How can you convert that division into a multiplication? Yeah, you could, instead of dividing this by h, it's the same as multiplying by 1 over h. So I'm going to multiply that times, I'm going to multiply that by 1 over h. Now, why would I want to do that? Why would I want to change it and make it look like that? Okay, I still have a fraction times a fraction, but what happens to h? They canceled out. So f of x plus h minus f of x over h is actually equal to negative 4 times 1 is negative 4 over x times, or x plus h times x. So that's what this is. That's the equivalent. Here's the last part, because this was step 3.
If we do a little bit of it in a day, like maybe not, you can tell that we worked through it, but we
Yeah.
don't do every single step, we'll still get.
Yeah, I'm trying to do every single step so that you don't miss anything.
Yeah.
Okay, I'm going the whole 9 yards.
I just know on the test, you want to see our work on.
I want to see the 4 steps. Now, how much you can do of those 4 steps in your head is okay, but if you start making a mistake and, you get confused, then you need to go back and put in all steps. Okay? Now, step 4 is the last step. And all we're doing in step 4 is we're going to take the limit as h approaches 0. In other words, at this point, we're going to can you actually let h be 0 now in this expression? Does anything bad happen? What happens when you take x and add 0 to it? Yeah, it just, h goes away, it just becomes x, right? So when you take the limit, what do we actually have then? Does it change -4? No. What's x times x? Okay? All of that work, because we started with a fraction, to find f prime of h, or I'm sorry, f prime of x, and f prime of x turns out to be -4 over x squared. Okay? That's probably the hardest one. That's why I wanted to go through the whole 4 steps with you piece by piece by piece. That's probably the hardest one. Anything that's a fraction is always harder than any of the others. Okay? Now I'm recording this and I'll have it up by tonight. It takes about from now until the time I go home. When I stop it, by the time I get home, it's ready, and then when I get home I tell it to upload to YouTube, and it takes maybe 10 more minutes to upload to YouTube. So you'll have it by tonight in case you need to fill in your notes or go back over this.
Did you ever post 11.2?
I have 11.2 recorded, and when I get home I've got to put it up too.
And I was looking at integrity the other day, and it's surprising how my professors weren't doing it. Do all professors use integrity?
No.
No. Do you use integrity?
I use Tegrity when I'm recording in the classroom. I use Tegrity sometimes when I'm recording in my office. Anytime I'm trying to show you the calculator, I always have to use Tegrity because I can't show you the calculator without Tegrity. But when I record at home, I use Explain Everything or Show Me, and I have a little document camera at home that I can actually write on things too.
Okay. How do we access that?
Hmm?
How do we access that?
I actually upload my Tegrities to YouTube, and then I post the link in YouTube. So if you go into Show Me and you click any of those links, it takes you to my YouTube channel.
That's right.
Yeah. Because sometimes, like yesterday, D2L goes down, and then you can't get easily to the Tegrity link, and you're sitting there saying, I need to watch that video, and I can't get to it. So YouTube is available 24/7.
Yeah.
Okay? And you can subscribe to my YouTube channel so it'll take you straight to it. Okay, let's look at an application. And actually, I'm going to post this whole PowerPoint up there. Just please don't print it. It's like 55 pages long. Just look at it online in case you need to, because it's got all the same stuff that I did, but I think it's better if we go slow and let you see it. And then I actually showed you there how to do it on a graphing calculator, but I want to actually do a recording with the calculator up there and me pushing the buttons so you can see it. So this is the one that we just did. Now, as you can see, it took several slides to do that one, so here's where we are now. Okay, this one says the cost in dollars to manufacture X graphing calculators is given by this cost function. Okay, now you may have had the idea up to this point that cost functions are always linear, but they're not. They can be any kind of equation in the world. So the cost is given by C of x is equal to negative 0.05 x squared plus 20x plus 150 as long as x stays between 0 and 2000. Find the rate of change of costs with respect to the number manufactured when 100 calculators are made and when 1,000 calculators are made. Okay? In other words, the rate of change when exactly 100 calculators are made. That's the derivative. And you look at that and you say, oh my God, I have to take the derivative of that. It's not as bad as you think it is. It's long in the first step, but it collapses pretty quick. So we're going to have to find the derivative of the cost function, and then we're going to plug in 100 to find the rate of change when 100 calculators are made. And then I'm going to tell you what that means. Once we've found it, I'll tell you what it means. And then we're going to do the same thing when 1,000 calculators are made. Okay? So we're going to go once again step by step, but because I know it's going to take some room, I'm going to get a sheet of paper and copy down this cost function. So what we want is we want to find C prime of X. So we're going to do step 1. Actually, and since it's a C, I'm going to stay with C. I need to find C of X plus H, which means I'm going to plug in X plus H into those two places. I should have planned a little better and not written so big. So, C of X plus H. We need to simplify. What is X plus H? Quantity squared. It's exactly the same as it was when we did the first one. Okay, good. And then I need to multiply that by negative 0.005, which I will in the next step. And then I'm going to multiply 20 times X plus H. And then I'm going to add 150 to the whole thing.
So since you kind of know it's going to end up being in parentheses X squared plus 2X H plus X H squared.
Could you skip that step?
Can you go ahead and skip to that?
Yeah. So C of X plus H is equal to negative 0.005 X squared. And then I need to multiply that by 2. And just to be sure I don't mess up, I'm going to grab a calculator and multiply it on the calculator, even though I shouldn't have to. And I get negative 0.1. And that's X, H. And then minus 0.005 times H squared plus 20X plus 20H, oops, plus 150. Do any of these combine at this point? Nope, that's as simple as it gets. So the final result of step 1 is C of X plus H. Even though it's long and kind of ugly, the math really wasn't hard or shouldn't have been. Negative 0.005 X squared minus 0.01 XH minus 0.005 h squared plus 20x plus 20h plus 150. That's going to be the longest step in the whole problem. My next step is where I take c of x plus h minus c of x. So I need to take this and what I'm going to subtract from it is this. Now when I subtract that, what's going to happen to all those signs? That's going to become positive, that's going to become negative, that's going to become negative. Agreed? Hopefully at this point you'll see what the goal of step 2 is. This is a 4-step process, okay? But the result of the 4-step process now is that that goes away, and that goes away. So it shrinks.
Why is it that you cancel this? I mean, I know that you cancel out the positive and negative, but what did you do to get the, they switch the signs?
You just switch the signs. When you subtract anything,
Yeah,
you
but-
add its opposite.
Yeah, where are you taking it though? Like, don't you have to do the same with both sides?
You're not solving an equation.
Oh,
Okay? I'm taking
yeah,
this minus that,
okay.
okay?
Yeah.
Which is why, in order to just save time, when I subtract c of x, that means that sign changes, and that sign changes, and then I just add it to the other part,
Yeah.
okay? So is everybody clear on how we got this? Okay, this is smaller. So the result of step 1 is always going to be this big, huge, long, ugly thing, and step 2 actually makes that a little bit smaller. Because the goal is to actually cut out some of those earlier terms. And if this doesn't happen at that point, if everything you have left doesn't have an h in it, you did something wrong. Go back and see what you did. Because when you get to the end of step 2, everything should have an h in it. Okay? Then your next step is to put that whole thing over h. So you take that negative 0.01 xh minus, and this would be where Chris would want to go ahead and just kind of eliminate some steps. He probably wouldn't recopy. He'd draw a line under it and write h. And normally I would too. Because that's really all you're doing is you're taking this and you're going to divide the whole thing by h. And hopefully you see at this point why it's important that every term you have left has an h in it. Because that's what's going to let you get rid of this one.
I'm sorry, this is my son like Bill's question. Where did the H come from? Why did you divide?
That's the next step.
Oh,
Okay? That's just the next step. Actually, these first 3 steps are how you find the difference quotient. The the quotient of a secant line. Okay? Only the last part of it turns it into the derivative. So what I want to do now is I want this not to have an h in it. I would like to get rid of that h in this expression. And the way that I can do that is I'm going to factor out the h. That h, one of these, and that h. Because when I do that, only one of these terms has an h in it, and I'm not going to divide by 0 because there's no h in the denominator anymore. That was the reason to do that. So this part right here is c of x plus h minus c of x over h, but the h disappeared. So now what I want to do, this is the last step. I'm going to kind of leave out a little bit in there and go to the last step. The last step is I'm going to do the limit as h approaches 0 of this but this whole thing here is equivalent to that. So what happens to this when I let h approach 0? Does it change that? No, because there's no h's in that. Does it change this? No. Does it change this? Yes. What does it make it do? It becomes 0, because if h approaches 0, that's gone. You shrunk it right out of existence by multiplying it by 0. And you can do it there where you couldn't do it here until you actually factored out and got rid of the h in the denominator. So your derivative, this is actually now your derivative. That's the derivative of that function. It took a whole page to do it. I know it did. I'm going to make you appreciate the next chapter, believe it or not. That's what this did for me when I had to learn this, was it made me appreciate the next chapter a whole lot more. So, find the rate of change of cost with respect to the number manufactured. That's the words for derivative. And this is dollars. And since it's a rate of change, that's per X calculators. And that's because it's a rate of change. That word per comes in there, miles per hour, dollars per calculator. Now, this part's easy. This part you shouldn't be worried about. When you make 100 calculators, so negative 0.01 times 100 is actually negative 1. you move the decimal 2 places by multiplying by 100. So the marginal rate of change, or the marginal cost, the rate of change of cost, when you made 100 calculators, is $19 per calculator. Now, interpretation-wise, what that means is it costs $19 to make the 101st calculator. Okay? It takes $19 to make the next one. And then for 1,000 calculators, let's see, move it 3 decimal places, you're going to get -10. Which is 10. And that means the 1,001st calculator only costs you $10 to make. Okay? I want you to think, and this is not calculus, I want you to think as business people, why would the 101st calculator cost you $19 to make, but the 1,000th calculator only costs you $10 to make? Why would that change so much?
Because your max profit is marginal revenue, or whenever marginal revenue multiple cost match.
That's where you're making your, that's where your marginal profit is equal to 0, where your profit's not changing. So that's related to it. Think about this. Marginal cost is always marginal cost per item, but you also have something else. You have a fixed cost, right? If you only make 10 items, what part of that fixed cost goes for each item? Let's say your fixed cost is $100 and you make 100 items, and what's your fixed cost per calculator? It's going to be 1/10 of that, or, yeah, it's going to be 10%, okay? So 10% of $100 is going to cost you $10 of your fixed cost for each calculator. But what if that suddenly goes to 100 calculators and your fixed cost was 100? You pay $1 per calculator in your fixed cost, right? So if you make 10,000 calculators, how much of that $100 goes on every calculator? A very little bit of it. What's happening is that as you make more and more and more of the product, your fixed cost at the beginning, I mean, that's what eats up your profit when you're first starting out. You're only able to make just a few, you know, your chances of making good profit are pretty small because you can't make enough to overcome your fixed costs. Think about opening a factory. You have to build a building, you have to get the utilities, you have to buy the licenses, you have to hire the people, got a lot of upfront fixed costs. And let's say the first week you only make 10 of your product. Do you really think you're probably going to make much money? Not that first week. But now you've got your building, you've got your fixed cost, that's paid. That's going to be paid, that's behind you. So the next week, you actually just get off the ground and you make 100 of your product. Or you maybe starting to get closer to the break-even point. Yeah. And then by the end of the month, you're able to make 1,000 a week. Do you think you might start realizing profit when you're making more of them than when you were making fewer of them? And the reason is because your fixed costs now are not spread over 10. Your fixed cost is spread over hundreds or thousands. And that's what this is showing you, because this is a realistic cost function. Some costs, some marginal costs, and both of these are actually marginal costs. Some marginal costs don't change, but they have different coefficients. They have different ways of growing. But this never changes, so the more you make, the less of this actually applies to every one that you make. So your higher numbers of calculators cost you a lot less to make. Eventually, they're going to cost you $1 a piece. Only, but, you know, at 2,000, I don't think that's going to happen. Now, the last part we want to talk about, and then we're done. Do you remember being able to find continuity? I talked about that a couple of times. I know you don't have the whole lecture on it, but I gave you the ways to find continuity at any point. What is required for a function to be continuous at any given point? It has to be defined at that point. It can't be a hole, right? Can't be a hole, can't be an asymptote. In order for it to be continuous, not only does it have to be defined, but you have to take the limit from the left and the limit from the right, and they have to come together. They can't do like this. 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 Okay? They have to come together. They have to meet. If both of those things happen, and the place that they meet is actually where the function is defined, it's continuous. This is a similar process. A derivative only exists when the right-hand limit is equal to the left-hand limit. The idea behind this one, where does that function do something odd? Where does it change rules? Yeah, at 0 it changes rules. It goes from being x to being negative x. This is actually the definition of the absolute value. Absolute value of positive numbers is positive. Absolute value of negative numbers is the opposite of the number you started with, which actually turns out to be positive anyway. If x is -1, then it actually turns out to be the opposite of the -1, which is +1 again. So this is your absolute value function. It's the best one to explain to you what I'm talking about when a derivative exists. You can do it by the limit rule, but the reason this one gives you tells you that the derivative doesn't exist, and I'm going to give you the common sense reason, not the math reason. At this point right here, you can't draw a tangent line that has a unique slope. Here's a tangent line at that point. Here's another tangent line at that point. Here's another tangent line at that point. Anytime a function comes to a sharp point, the derivative doesn't exist. Okay? I want you to be able to interpret these visually, not by doing a lot of math. You could take a derivative here, it'd be 1 because the slope of that line is 1. You could take a derivative on any of these on this side, and the derivative would be -1. Okay? But when they come together, even though the function is defined at x equals 0, what happens is in the limit, if you actually try to do the limit, it will come out to be the absolute value of h over h, and if h approaches 0, that's going to be 0 and that's 0, and you get something that's totally undefined. So the only reason I left this one in here and talked to you about it is to try to get you to understand what the derivative tells you. The derivative is the slope of a tangent line. Not a secant line, a tangent line. Okay? This is a cube root function. The derivative right here is the slope of a tangent line. We talked a little bit about this last time. We talked about that point where we were on something that was kind of curvy like that S, and at some point, if you tried to touch that function in one point, you wind up on this side of the function on one side and on the other side of the function on the other side. It didn't touch it and go on. It cut through it. But what makes it worse is at this point your tangent line is vertical. What is the slope of that tangent line? What's the slope of a vertical line? 0 is this way. What's the slope of a vertical line? Undefined? So the derivative at 0 on this particular one, it does not exist. It's undefined because it's vertical. I'm going to talk to you about this picture, and you'll probably see this picture again at some point, so I pay particular attention to this part. You can't draw a tangent here or here that has a unique slope. Because remember, a tangent is supposed to touch it in one point and indicate to you what the function is doing, what the slope of that function is at that point. Well, I can draw this tangent line, I can draw that one, I can draw that one. And none of those really tells you what the function's doing though, because the function's reached a peak and then changed direction. Same thing here. This one, there is no derivative here, because if you take the limit as you come at it from the left and the limit as you come at it from the right, you approach two different places. So it's a matter of it not being continuous there, so the derivative doesn't exist there. And it's because it's not continuous there. And your right hand and left hand limits don't meet. It's defined. F of x is defined at that number, but the limits don't meet. Here, your function is simply not defined, so you can't have a derivative at whatever that number is either. Even though your limits match, because they both go to positive infinity, the function itself is not defined. So it fails the first step. The only thing we're adding here is that this is vertical, which we didn't talk about last time. And because it's vertical, the slope is undefined. And so the tangent does not exist. Derivative does not exist. Here the function is not defined, but now here's the only place it's going to mess with your head. Is the function continuous here? Nope. It's got a hole in it. Right there. It's got a hole. So it's not continuous. But what you're going to find out is that the derivative, because your left-hand limit and your right-hand limit come together at the same point, the function is not defined. But the derivative does exist. That's because your limits matched. So there was no derivative here, no derivative here, no derivative here, no derivative here, no derivative here. But it does exist here. This is not continuous. This is continuous. Not continuous, not continuous. This is continuous. But the derivative doesn't exist. Okay? If you have questions over the weekend, I will be home and I will pay attention. And I will have that video loaded for you tonight. And I'll send you out a message as soon as it's up there and I can click on it and I can see it. If I can see it, you can see it.